Hello everyone, welcome back to the channel. In this video, we are going to discuss about level order traversal. First, we will discuss what a level order traversal is, its algorithm, code, working, time complexity, space complexity. So let's get started.
If you haven't subscribed to your channel yet, do subscribe.
So, these are some slides we are going to see. Level order traversal is also called breadth first traversal. Breadth first traversal is a kind of technique or an approach we use to traverse data structures like trees, graphs, etc. Initially, I thought I should start with BF search of graphs, but I chose first traversal of trees before that because there are very few differences between the two algorithms, and learning this first will clear things better for you. So first, even before I proceed towards the algorithm, I'll clear a couple of terms, search and traversal. So search is you have a target value and you intend to find it whether it's in your data structure or not. And traversal is you just want to travel the whole tree or graph and then print the values present in it. So the techniques we discussed today and further can be used either for traversal or searching through graphs or trees. The algo just needs a slight modification to cater the appropriate searching or traversal. If you see here, we have added a line called print data of front node in a queue. So in case if you are searching, you can just modify this to if the value of front node data is equal to target, then do etc appropriate action. So now here comes our algorithm. So our algorithm just takes root node as an input. So we start by creating an empty queue, and the next step is to check whether we have an empty tree, that whether the root node is null or not. If the root node is null, we return. This step is absolutely important because if we do any kind of operations on null pointer, we get into runtime errors. If it's not an empty node, we put the node in the queue. So now we enter the loop. So unless or until the queue is empty, we stay inside this loop. Queue is empty, which implicitly indicates all the nodes are visited, because tree is a connected data structure and we kind of have one path from one node to another, whichever node you pick. So we print the data of the front node in the queue, and then if the left child of the front node is not null, we put it in the queue, and then we similarly check whether the right child of the current node is null or not. If not, we put it in the queue, and then we pop the front node in the tree. So here I am going to represent the nodes in the queue with the blue color, and the nodes whose children are kept into the queue and they are visited with red color. So here initially we put the root node 2 in the queue, so it is in blue color, and then we print its value, and then we pop it off and put and check whether these nodes, its left child 1, whether it's null or not. It's not null, so we put it in the queue, and then similarly the right child 3, we put it in the queue, and the tree becomes as, see, we have popped off 2 and kept 1 and 3 in the queue. Since 1 is the oldest member in the queue, in this iteration the front node of the queue becomes 1. So now we check whether the left child of the 1 is null or not, and then corresponding right child is null or not. They are not, so we put both of them in the queue, and we got a pop of 1. So here comes our tree, and similarly the oldest member of our queue is now 3. So now we check whether there are only not null children to 5. There aren't any. So we just print the value of 5 and pop it off from the queue. Similarly for 6 there are no children, so we just print and pop. 7 print and pop. 8 print and pop. So we are done. So now let's just see the code. I have written the code in C++, so you can choose any language for that matter. This is our code. The method level order traversal takes the root node as an input and it has the return value of void. Since we are not returning anything, we are just printing the data of the nodes in the method itself. So as we discussed earlier, it just checks whether the root is null or not. If it's null, it will return. And then we are creating a queue to store the node pointers pointing to the nodes of the tree. And then we create a temporary node pointer to store the front of the queue, and then we are going to push the root node into the queue first. Now we enter to the while loop. So as long as queue is not empty, we are going to store the front node, that indicates the oldest node of the queue, in the temp variable, and then we are printing the data of the temporary variable, and then we are of the first element of the queue. So this indicates we are removing the oldest element of the queue. Now, if the current node has any left children, we are going to push that into the queue. And if the current node has any right children, we are going to push that into the queue as well. So now we'll also be writing and running some code, and post that we'll be discussing about the space and time complexity. I've already solved this before, so I'm going to take this off. So now, first, in this method, we are not printing the values in the tree. Instead, we are adding them to an vector and then giving it as an output. So let's just create a vector of type int and I'll name it as result. So now we'll check whether the root node provided as an input to this function is null or not. So if node equals to null, return result. Now we're just returning an empty vector when the root node is empty. So next we are going to create a queue to store the node pointers of the tree. So it's queue node star queue. So queue dot push node, and then I'm going to create a temporary variable node star temp to store the front of the queue. So as long as the queue is not empty, we are going to loop through the elements of the queue and then add the children to the queue, so that we'll cover all the elements of the tree. So we'll just take the front variable of the queue in the temp, and then we'll just pop the front variable, and then so we are going to push the value of the temp variable in the result vector. So it's result dot push underscore back temp hyphen data, and then so now we are going to check the left and right pointers of the current node. If they are not null, we'll add them to the queue. So if temp hyphen left queue dot push temp hyphen left, and then if temp hyphen right queue dot push temp hyphen right. And I think we are done. Let's just run the code. Yep, it worked, and then let's submit it. So we are done. So we'll now just see the space and time complexity of our algorithm. So now let's see the time complexity and the space complexity. I'll be calculating time complexity step by step. Now all these steps, checking whether the route is null or not, creating a queue, pushing the route to the queue, all this takes a constant time. And also in here, taking the first value of the queue, printing its data, popping it, and checking whether the left child is null or not, and adding it to the queue. All of these take constant time. The loop here runs for n times. It runs once for every node in the tree. It starts with the root node and then it went to the first child and second child and its children and its grandchildren. Coming to space complexity, the space complexity is also of n, where n is the number of nodes in the tree. As we can see here, the temp etc. take occupies a constant time, and the space complexity contributing factor is the queue here. So as you can see, at a given point of time, the number of nodes in the queue will always be less than n. So the space complexity is also will be of n. If you like this video, do like, share, subscribe.